Hello everyone, I hope you all are doing great. Today in this video we are going to discuss Airbus A320's hydraulic system from Airbus FCOM. Before starting the video, let me please clear you a few things that you can use playback speed of 1.5 or 1.25 because my rate of speech is very low and this video is just a screen record and I do not use cuts and editing, so relatively rate of speech is slow, right? Disclaimer: I do not own any of the images and content used in this course. All of it is a reproduction of Airbus manuals just to serve the purpose of easier understanding of the system and procedures. I do not recommend any practical application of this and information of any information in this course in real world scenarios, right? So let's start. Hydraulic system from FCOM. I have taken screenshots of hydraulic system from FCOM. There are hardly 8 or 9 slides and I have taken few photos from Google to just make it easy for you, right? Hydraulic system. In this hydraulic system we will talk about some general description of hydraulic system. Then in that we will discuss green system pump, blue system pump, yellow, then PTU, how does PTU function, then what is RAT, how it works, then we will talk about priority valves, then we will discuss about fire shutoff valves, then leak measurement valves, and then so on, reservoirs and all. And thereafter we will discuss about the distribution and then controls and indicator of this chapter, right? So let's start. So our aircraft has three main obviously only three hydraulic system, which are green, blue and yellow. Each system has their own reservoir and the normal operating procedure is 3000 psi. Okay, so how does it look like if we look at the schematic diagram of it? Just a second. This is a black and white and a schematic diagram from the FCOM. I have taken a colored picture of it from the Google. Here it is. Here it is. So we have three systems: green, yellow and blue. These are the reservoirs. Then further downstream we have engine fire shutoff valves for both engine driven pumps. So first thing first, we have one engine pump for green system, we have one engine pump for yellow system, right? This is engine driven pump. When we start the engine of our aircraft, then our aircraft's N2 shaft is connected to accessory gearbox and then it is connected to engine pump also, right? So in this manner we have two engine pumps for left and right engines. Then for specifically for yellow system we have a electric pump also and a hand pump for cargo door operations. This electric pump is independent of engine engine status. If engine is running or not doesn't matter, but if we have AC electricity, AC supply in the aircraft, we can use electric pump of yellow system, correct? For blue system we have electric pump and a ram air turbine. We will discuss about each pump one by one, but now we are just going through the schematic diagram of hydraulics. Then further down the stream we have accumulator. What are they, how do they function, we will talk about them, right? Then we have a PTU, which is power transfer unit, which connects green system with yellow system. Then further, now we have leak measurements valves just before the controls, and I should say just before the actuators or hydraulics. Now this pressure is given to different systems further, right? Let's say for an example, if we'll talk about green system, then green system supplies landing gear, flaps and slats. Similarly, yellow system supplies flaps. When blue system is pressurized, it gives pressure to slats and other control surfaces, lateral and for pitch controls. We will discuss about them also, how to remember each flight control, which is powered by which hydraulic system, right? Normal braking is with green system, normal brakes, but alternate braking is with yellow system. Is it clear? Right. So okay, reversers of each engine is pressurized or connected with their own respective hydraulic system. For left engine reversers, it's the green which supplies the pressure or the power, and for the right engine it is yellow system which supplies the pressure to the reversers. Correct. Okay, we have priority valves just before the heavy load users. We will talk about them also. Right. So now you have a basic idea of all hydraulic systems of Airbus A320. I hope it's little clear for you right now. How does it look like and how uh, it can be represented on a paper. Now let's go back to our FCOM. Now you will be able to understand, now you have a clear picture in your mind about the hydraulics. Okay, again, normal system operating procedure is 3000 psi. The all three systems, blue, green and yellow, all are pressurized at 3000 psi. But if rat is powering, then it is 2500 psi. Okay, when does rat works and how it pressurize? Let me show you again. Here we have rat. This is ram air turbine. How it looks, it's a turbine basically, and it extends from the belly of the aircraft like this. This is ram air turbine, right? It drives a emergency generator, okay, and it pressurizes the blue hydraulic system in case of emergency when we do not have power on the AC bus 1 and AC bus 2, right? Okay, let's say we have lost power on AC bus 1 and AC bus 2, then this rat extends and it supplies and pressurizes blue hydraulic system through hydraulic motor, right? So it is shown here. It pressurizes. Whenever rat is pressurizing, it pressurizes the blue system with 2500 psi. Keep it in your mind. Otherwise, in normal condition, all three system pressure of all three hydraulics are is 3000 psi. I hope it's clear now. As I am covering each and every line of FCOM, this video may be a little lengthy, so please keep it in your mind. I cannot end this video within a 20-minute or 30-minute. It is little impossible, slightly impossible, right? The next page is okay. One more thing, hydraulic fluid cannot be transferred from one system to another system. If some fluid in the green system will remain in green, if fluid is in yellow system, it will remain in the blue system. Correction, if it's in yellow, it will remain in yellow only. Now we will discuss each system one by one. Green system pump. We have one engine driven pump for the green system. I have shown you. For blue system, we have an electric pump that pressurizes the blue system. It is totally automatic. Whenever any of the pump, any of the engine driven pump starts working, this electric pump of blue system starts automatically and starts supplying pressure to the whole blue system. Except this, we have a pump driven by a ram air turbine pressurize the system in the emergency. Okay, whenever any of the engine will start on the blue system starts working. I have told you this. When we consider that it's a hydraulic emergency or what, whenever two hydraulics are failed, then it is considered as a hydraulic emergency. Just it's the extra information, extra from the FCOM. What is yellow system pump? How yellow system is pressurized by pumps, different pumps. So we have one engine driven pump. It's a axial flow pump. Do you know whenever engine RPM N2 RPM is around 5 to 7 or 8%, these systems get pressurized at this low RPM of N2. Can you imagine how capable our engines are to pressurize the system? Right. Then we have a electric pump and we have a hand pump for cargo doors operations. Is it clear? Let's say if you don't want to pressurize the system, whole system, and you wants to operate cargo doors for the some maintenance work or something, then you need not to pressurize the whole system. You need not to start the engine number 2 or whatever. You just use hand pump which is near the cargo doors, and you can just open the door. All right. What is PTU? PTU is power transfer unit. As it is clear by its name, power transfer unit. It does not transfer any liquid between the systems. Okay, the main thing is it is basically a system which transfers pressure from one system to other system whenever any of the system has pressure differential of 500 psi. Okay, right. Let's say this blue correction, it is a connection between green and yellow, right? It is not connected with blue. Keep it in your mind. One thing, if pressure in this pump is, let's say it's x and here it is x minus 500, then PTU will come into play and it will pressurize the yellow system. Correct? This is how it works. Let's go back to our FCOM. Here it is. It's a bidirectional power transfer unit, enables the yellow system to pressurize the green system and vice versa. The power transfer unit comes into action automatically. It's a totally automatic function when the when the differential pressure between the green and the yellow system is greater than 500 psi. Or keep it in your mind, whenever the pressure difference exceed 500 psi, PTU works automatically. If it does not work, then after 650 psi's difference, the fault light of a PTU illuminates on the overhead panel. The PTU therefore allows the green system to be pressurized on the ground when the engines are stopped. Is it clear? Read it again. The PTU therefore allows the green system to be pressurized on the ground when the engines are stopped. Let's say both engines are not running, right? How it helps to pressurize the green system? We have switched on electric motor of yellow system. We have a switch on the overhead panel. We have started electric motor of yellow pump. Now this system is pressurized. The whole system is pressurized. Then this PTU enables green system to be pressurized, because this system has pressure, this green system doesn't have. So it will pressurize the green system and green system will start working, right? I hope it's clear now. This is overhead panel, right? We have indications for engine 1 pump, then engine 2 pump, engine driven pump 2. Clear? Then we have electric pump on the in the yellow system. This is the one I was talking about. We will switch on this electric pump if we have electrical power. Let's say we have external power or APU or anything. We can switch on this electric pump, and this will pressure. PTU will help green system to be pressurized. This is diagram is it's very clear by looking at this diagram on the overhead panel, right? Let's go back. Here we were. What is ram air turbine? It's a dropout rat coupled to a hydraulic pump that allows the blue system to function if electrical power is lost for both in or both engine fails, right? The red deploys automatically if AC bus 1 and AC bus 2 are lost or if they are not powered. Let's say both engines has been shut down and both engines have failed, then in flight this red deploys automatically because bus 1 and bus 2, AC bus 1 and AC bus 2 are not powered, right? If you are facing difficulties to understand this logic, then you can watch the video of system electricals, right? Now after that it will be very easy for you to understand, but I will make a diagram here for you. Let's say it's engine number 1, this is engine number 2, then in the downstream we have AC bus 1 and AC bus 2 just after the engines. So if let's say both engines are not working, then these buses are not powered. Whenever it is sensed that both buses are not powered, it means now it's an emergency situation. So this rat deploys automatically. It's automatic function. Do not expect this video to be just a 20-minute or 15-minute video, and you are hoping that after making a 15-minute video you will be able to understand the whole hydraulic system. Please, it's not that small chapter. Please try to understand. And I would like to tell you a few things, like I'm not a professional teacher, so please do not expect very good teaching skills and all. Number two, I'm not a professional YouTuber. Please do not think or expect fancy editings in my videos. I just make raw videos. I just screen record them and just upload them raw. So that's why there are very high chances of slip of tongue and some maybe wrong information or something. So if you find any, please let me know in comment. I'm just a student, and uh, I'm also learning A320 system. I will be happy to know and will correct myself definitely, please. Now moving forward, it can be deployed manually from the overhead panel. It can be stored only when the aircraft is on the ground. I hope it is clear. If not, then I will clear it. It can be deployed from the overhead panel manually. So we have this button on the overhead panel, rat man on. We will pull this switch, guarded switch, and we will press button inside it. Right? Why it is red guarded switch? It means the application will, the effect will be irreversible by pressing this switch. Is it correct? Yeah, is it clear for you? If we will press the button inside it, then the system on the the actions will be irreversible. So the rat will deploy, and you cannot stow the rat in the air. You need an engineer on the ground to stow it back again in the its bay. Where is that? Here it is. Only engineer will stow it again in the on the ground. Right. Mm, Here we were. It can be stored only when the aircraft is on the ground. Okay, where can we see the status of rat? That rat has been deployed or not, whether rat is working or not. So we can see on the hydraulic ecam page about the rat, that rat is applying pressure or giving the pressure. System accumulator. What are accumulators? Basically these are I would say some piston like things which store some pressure in themselves, and they helps to maintain a constant pressure by covering transient demand during normal operations. If there are some fluctuations and you have just demanded so many controls, or I would rather say you have given so many commands to the different hydraulic systems, so the system accumulator helps their respective hydraulic system to just by giving a constant pressure by covering transient demand. They gives the initial pressure, the initial supply when you ask for uh, any hydraulic to work. What are priority valves? Priority valves prioritize the pressure in case of any emergency. So where are these priority valves are? These are just before the heavy load users. These are just before the heavy load users. These are heavy load users. You will come to know, just look at the size of a landing gear. Can you imagine how much hydraulic pressure it will require to extend them or retract them? Same with flaps and slats. Same with flaps and slats here, right? These are small, relatively small control surface. Let's say left spoiler number 5, left aileron, left slat wingtip brakes, and all these are relatively smaller control surface and do not need that amount of pressure and hydraulics. So these priority valves cut off the supply from the heavy load users. Now the supply has been cutted down to these from these systems and will be given to these only. Is it clear? Now you will think, when these are some important I would say users, hydraulic users, how can you cut the supply? Okay, let's say there is a fault in green system. There is a fault in green system. this priority valve will cut the supply of landing gear and slats. By the way, I would like to clear this thing here only. Nose wheel steering is no longer with green system now. It used to be with green system in older aircrafts. Now nose wheel steering is with yellow system, right? So let's say if this priority valve cuts the landing gear and flaps slats from the green hydraulic system in case of any emergency, then landing gear can be lowered or extended from by using gravity extension. Is it clear? You will rotate that gravity extension 1, 2 and 3 clockwise direction, and the landing gears will be down, right? So you can use landing gears easily. Same with flaps and slats. Flaps are also getting powered from yellow system, and slats are also getting hydraulic power from the blue system, right? So there is, it's a fail safe, these are the fail safe users you can use even after cutting the power from the systems. I hope it's clear. Now priority valves are clear, I hope. I know I repeat things again and again, but it's for you only. But the things will strike in your mind again and again, and you will your mind will register them easily. That's why I repeat things again and again. So priority valves cut the hydraulic power to the heavy load users if hydraulic pressure in the system gets low. Right? What are fire shut off valves? What are fire shut off valves? In case of engine fire, and you have pressed engine fire push button from the overhead panel, there are three fire push buttons on the overhead panel. This one is for APU, this is for engine number 1, and this is for engine number 2. These are red guarded switch, and these have red colored lights in it in case of any fire and something like this. So whenever you press these push buttons, they also cut the fire shut off valves. They cut the supply of these uh, valves. Where are these? These are just before the engine driven generators, correction, engine driven pumps, just before the engine driven pumps. And by looking at the diagram, you will be able to figure it out that we have only two engine driven pumps, one for green system, this, let's say this is green system, this is green reservoir, and one for yellow system. For blue system we have only one electric pump and one rat. Clear? For yellow system we have three things. One is engine driven pump 2, this is engine driven pump 1, another thing is electric pump, and third thing is hand pump. Correct? So we have only two engine driven pumps, and so the fire shut off valves will be just before these pumps. So these are fire shut off valves, or I should show you there only. Just a second. Just a second. This is the diagram. Can you see the engine fire shut off valves? Just before the engine driven pump. Right, it's clear now. Again, we are going back to our FCOM. Now engine leak measurements valves. So each system has a leak measurement valve upstream of the primary flight controls. Upstream of the primary flight controls. These valves will measure any leak in each circuit. They closes automatically in case of any leak. Are closed by operation of the leak measurement valve push button switch on the maintenance panel. On the maintenance panel we have this switch, and we can close the operations. Filters, this is L3. You know what L3 means? It is some extra information, and okay, if you are reading it, it's like that. I have made a separate video of what does L1, L2 and L3 means in aircraft philosophy, A3 Airbus philosophy. You can watch that video also. It's very interesting. Filters can clean the hydraulic fluid as follows: HP filter on each system and one on reservoir filling system and the normal braking system. Return line filters or each line, and so on. Right, these are filters. This is a schematic diagram. This is similar to the colored one I have shown you. These are reservoirs, and then the same accumulators and pumps here. Right. Okay, now we will talk about reservoirs and their pressurization. Right. So we have three reservoirs. Am I right? We have these three reservoirs, and how do they get pressure? You need to pressurize the system, any fluid system, so that pressure comes from in engine 1, bleed air of engine number 1. So okay, yes, here it is. These are the three reservoirs. You need to pressurize, when you go in the air, the pressure outside is very low, and if you are taking fluid from here, then you need to pressurize the reservoirs from here. So from where does this pressure comes? It comes from the engine 1 HP section only, right? Is it clear? If not, if engine 1 is not running or is not working or something goes wrong, then this pressure is taken from cross bleed duct. You can easily figure it out, and you would be able to understand very easily once you have finished pressurization or pneumatics. I would say pneumatics or pressurization. It will be very easy for you to understand if you want to go and watch pressurization and ventilation correction, pressurization and pneumatics, you can please. Okay. Normally, HP bleed air from engine 1 pump pressurizes the hydraulic reservoirs automatically. If bleed air pressure is too low, the system takes bleed air from the cross bleed duct. The system maintains a high enough pressure to prevent their pump from cavitations. Okay, why we need to pressurize the system, these reservoirs? Otherwise, if we will not pressurize these reservoirs, then further down the stream, okay, here it is, these after these reservoirs fluid directly goes to the pumps after fuel shut-off valves. Now pump will have cavitations because of the bubble blasting. There will be bubbles in the fluid if they will not be pressurized, and they will damage the pumps. Are you getting it? Right. There will be holes. Mm, let's say this is the pump. Okay, this is the pump. So at the there will be bubbles and damages on the engine driven pumps, the fans of the engine driven pumps. So that's why they get we pressurizes these reservoirs. I hope you are getting it. Next slide is this only. In this slide, I think this is the last slide in which after that the chapter ends, and next is controls and indicators only, right? Okay. Just a second. Right. So there is a fault light. If you have ever noticed on the overhead panel for engine 1 pump, one light for engine 2 pump, then for electric pump of yellow system, blue system also. Okay, when does that fault light comes? What are the reasons of that fault light? You know which fault light I'm talking about? This is the one. Just a second. These are the engine 1 pump and engine 2 pumps. This is the electric pump. Okay, when does this fault light comes? This fault light comes. What are the reasons? So here are the reasons. You can figure it out from here only. Whenever there is low level in the reservoirs, low fluid levels in the reservoir, then this fault light comes. Whenever there is fuel temperature is high, fluid temperature is high, then also this fault light comes. Engine 1 fault light. There are total 4 reasons, main reasons because of those this fault light comes. Now the third one is whenever there is low air pressure, bleed is not enough to pressurize this reservoirs, then also this fault light comes. Now the fourth and the last main reason is engine pump low pressure. No, engine is running, but the pump pressure is low. It's not 3000 psi, right? Then it also shows the fault light, right? Okay, when does this fault light comes? At what pressure? Whenever pressure drops by what what number, then this fault light comes. That is, it's very important. If it's a engine driven pump, then if it drops down to this pressure drops down to 750 psi, it shows low pressure. If it's a electric pump, now it's a engine driven pump only, but in case of electric pump, if it drops down to 1450 psi, then it shows, it is considered that its pressure is low, right? When it is considered that the system has low pressure, this is the pump low pressure, engine pump low pressure. When it is considered that system pressure is low, whenever the whole system pressure goes below 1450 psi, 1450 psi. So for electric pump and for whole system, it is the same number. Are you getting it? Okay. When does it comes normal, considered normal? When this pressure of engine driven, this is electric pump, the lower one. Just a second, I will make it a little clear for you. It's 1750 for engine driven pump. For electric pump, it's 1450 psi. Okay. When the pressure increases to pressure increases to 1750, right? Increases to 2200 psi. It becomes normal. And whenever for electric pump, it increases with 750 psi. It is considered normal. Is it clear? Right. It is little confusing, but I try to make you understand. I hope you are getting what I am saying. Right. Let's say these were the four main reasons of why this fault light of engine driven pumps come. Now for electric pump, we have electric pump too, na? So what are the reasons that the fault light of electric pump comes? This and this. So the four reasons are same like for yellow system electric pump. If the pressure low, if the reservoir level is low, if the fluid temperature is high, or if the low air pressure to supply or to pressurize the reservoir, and then engine low pressure, and fifth last thing is the temperature of electric pump on. If the temperature of electric pump because of its wiring or coiling increases after a certain limit, then also this fault light comes. So there are four reasons if we talk about engine driven pump, and there are five reasons. Fifth one is electric pump overheating for electric pump, right? So these are some reasons why this fault light comes. We are talking about fault lights only right now. We have completed our chapter. Now we are talking about controls and indicator of this chapter. Is it clear? Right. So I have you know told you about these things, why this fault light comes. If you will read this paragraph, then you will be able to understand that whatever I have told you is this thing only, that the reservoir low level that the reservoir level is low, reservoirs overheat, reservoir air pressure is low, and this, right? For blue electric pump, the fault light comes when the same I have told you, reservoir level is low, reservoirs overheat, and air pressure in the reservoir is low, and whatever. You can read FCOM calmly by sitting aside. There is nothing different. For yellow electric pump, fault light, the reasons are the same. I told you those five reasons. Yes, this one is important. PTU, push button switch. It remains in normal conditions in auto. You can see here this PTU remains in auto in normal conditions. We can switch it off by just pressing this push button. And when does this fault light of PTU comes? Right, we will talk about that. When does this fault light of PTU comes? Hmm. Whenever green or yellow reservoirs overheat. Are you getting? Whenever green and yellow reservoirs are overheating. These reservoirs are overheating because it is connected with these two hydraulic systems only, na? We will talk about green and yellow only. Second reason, there are three reasons only, and the second reason is green or yellow reservoir has low air pressure. Any of the reservoir has low air pressure. Third reason, whenever any of the green or yellow reservoir has low fluid level. So these are the three reasons when this PTU fault light comes. Let's say we have a low air pressure in the green reservoirs, then there will be two fault lights on the overhead panels. Tell me, whenever green reservoir has low air pressure, when will the where will the fault light will come? Look at the diagram. Where is the overhead diagram? This is the overhead panel, and we have green low air pressure here and here. Are you getting it? There are the two places where this fault light will come. I hope it is clear. Right. Let's go back to the page we were. Yes, we were talking about the PTU auto operations. Normally conditions, PTU remains in auto position. This bidirectional power transfer unit is armed when and both the yellow and the green electro-hydraulic valves are open. The power transfer unit runs automatically when the differential pressure between the green and the yellow system is more than 500 psi. PTU is inhibited during the first engine start and automatically tested during the second engine start. What does this mean? This note is important. This note is important. PTU is inhibited during the first engine start and automatically tested during the flight. So let's say we have started engine number 1. We have started engine number 1. Will now the green system will be pressurized, right? Will it pressurize the yellow system through PTU? No, there are some inhibitions. There are some inhibitions. It is assumed that the aircraft is not moving. Parking brakes are set on. It is assumed that aircraft is stationary and we need not to pressurize other hydraulic system through PTU. Right? Whenever we will release the brake, then the logic comes that the now aircraft gonna move and we need to pressurize the other system also through PTU. Then the PTU works and it pressurizes the yellow system also. And uh, users of yellow will be benefited after that only. Then we will talk about reservoirs quantity also. How much should be the quantity of reservoirs? When it is assumed that uh, reservoirs are fully filled or are at low level, right? We will talk about them just a minute. Now the next thing is rat man on push button. Rat man on push button. The flight crew may extend the rat at any time by pressing the rat man on push button. The rat extends automatically. We have talked about it, I think. If AC bus 1 and AC bus 2 are lost or if not powered. Right. This is maintenance panel. We need not to really go into the deep, but you can read it. There is nothing very important in it. I would like to skip it. A hydraulic ECAM page. Okay, so if the reservoir's temperature, fluid temperature is high, then overheat indication here comes. If pressure is low, pressure to pressurize the reservoirs is low, then here low air pressure comes, right? This is electric pump overheat. Same with the blue system. This is engine driven pump for green system. This is engine driven pump of yellow system, and this is electric pump of blue system, right? This is the indication of red. Now PTU is supplying green system from yellow. You can see these solid arrows. This is supplying a green system because engine 1 pump is low pressure. System pressure is 3000 psi. System pressure is maintained through PTU right now. You will be surprised that if system 1 pump is not running, it's showing low, then how it is 3000 psi over here. It is because PTU is working. This is the because of PTU only, right? Reservoirs quantity in the green, it is in green unless the fluid level goes below the warning level, where it is talking about this. It remains in green here. It remains in green unless the fluid level goes below the warning level. Now, what are the normal levels of reservoirs? For green, it is 14.5 liter. For yellow, it is 12.5 liter. And for blue reservoir, it is 6.5 liters of quantity, right? These reservoirs can hold or should be filled, right? And this is the normal acceptable level. Just a minute. Okay. These are the normal limits of reservoirs level. This is the minimum. Okay, it is considered that now reservoirs have reached their minimum values. And what are these for all three different reservoirs? It is 3.5 liters for green, 3.5 liters for this yellow system, and for blue system it is, I think, 2.4. We will clear it. It's 2.4 liter only. Here it is. Okay, so as I told you, this is the same line. This is normal filling. This is normal filling. Let's assume, let's start from here. This arrow will show that how much fluid these reservoirs have. If it is between these two, in this area only, it means that it is the filling is normal. And how much it is? It is 14.4 liter for green, 12.4 liter for yellow, and 6.5 liter for blue, as I told you. 14.5, 12.5, and 6.5 for blue. What are the low level warning? It is 3.5 for green, 3.5 for yellow, 2.4 for blue system, right? Okay, now you know how much quantity does these reservoirs holds. Okay. Hmm, anything important? Okay, when does this reservoirs overheat warning triggers, right? We were talking about this overheat, reservoir overheat, and in the engine 1 or engine 2 fault light also. This overheat warning comes whenever the temperature is greater than 93 degrees Celsius, right? And it becomes normal when temperature is becomes less than 88 degrees Celsius, if I'm not wrong, 80 or 88 degree, right? And this reservoir overheat here, reservoirs overheat comes whenever the temperature is greater than 93 degrees Celsius, right? Just a second, let me bring this here so that it will be easy for you to write. Right, now it's perfect. mm, what should I told you? mm, what is this? What is this? This is fire shut off valve. This is fire shut off valve. It is number 4. It's fire shut off valve. Cross line amber, the valve is fully closed. Whenever it's like this means valve is closed. And inline green, this valve is not fully closed, right? You can read it. It's just read and just keep it in your mind. What are the controls and indicators? There is nothing to really clear you, or I need to tell you. There is nothing like this in these controls and indicator. I should clear this thing. If indications are like this, it means PTU is supplying green system from yellow. It's yellow system. It's green. If these are like this, then yellow system is being supplied by green system. Clear? These are the normal conditions in which both hydraulic systems are doing their own, and they do not need PTU to be used. These are normal operations, right? Okay. Mm, I have told about the pressure already, and here the chapter ends. These are some memo. Hydraulic PTU. This memo appears in green when the power transfer unit is running. Okay, whenever PTU is running, then HYD, Hotel Yankee Delta, hydraulic PTU appears on the memo display, and rat out appears whenever the ram air turbine is not fully stored, right? Whenever it is extended, it is written rat out, correct? Okay, there are few things I thought I should clear you here only. If we have blue and yellow system low, landing gear should be by gravity extension to preserve the integrity of the system. You will be amazed that why we are using gravity extension in case of blue and yellow system, but landing gears are connected with green system to preserve the integrity of the system, so that the PTU doesn't waste its pressure, yellow system's pressure, to just extend the gears and whatever. That's why green and blue system fails, then the alternate law without reduced protection aircraft goes. If you are not able to get it, you can watch my flight controls chapter. It will be little easy for you. The speed protection will be from 350 knots to 320 knots. It's important. That's why you have to use selected speed. If we have green and yellow failure, then alternate law with reduced protection, correct? Here the chapter ends, and I would like to show you, this is how a hydraulic page looks like. This is something when low pressure is here. This is how a PTU looks like. This is PTU, right? And these are engine driven pumps. This is how they looks like. Okay, if you are willing to solve question answers of hydraulic systems, I would like to request you to please watch landing gears video or read landing gear from FCOM. It will be easy for you because landing gears and hydraulics are interconnected, because it's in green, from green system only, na. Then in landing gear we will talk about alternate braking, Then they will talk about yellow system, you know what I'm saying. They will talk about parking brake, they will talk about alternate braking, then they will talk about green yellow system only. That's why I would like to uh, just suggest you to read landing gear first, right? So in the end, thank you very much. I hope now you have better understanding of this hydraulic system. If you found this video helpful, please let me know in the comments. It will be more than enough for me. Thank you for your time and support. Thank you.